Hi, you are watching Arduino Floodlight Web UI. My name is Kashif Baig, and I will be demonstrating a project that has been developed using a new MVC framework and which promotes a professional software design. This is the third of 6 projects in increasing order of complexity. Visit my website to download the source code and framework libraries, and whilst you are there you can find out about my ebook, Arduino Web Development Pushing the Limits. It lays the foundations of a professional approach to web development using the Arduino platform. It has lots of coding examples and exercises to get you upskilled quickly. And so back to the presentation. You can build the source code using the latest Arduino IDE. I recommend using the freely available Visual Studio Code if you want to take advantage of Arduino server pages. Watch until the end of the presentation to find out more. To build the Floodlight Web UI project, you will need a network-enabled Arduino or compatible, and it will also help if you have a 9-in-1 sensor shield. But if you don't, just adapt accordingly. I'll be using a light-dependent resistor or LDR, and I'll also need a passive infrared sensor as shown. By the way, if you are using a classic Uno, the shield LEDs won't be available for use. You will need to attach your own LEDs. So for this presentation, I'm going to be using an Uno R4 WiFi. Connecting a web client to the Uno, we can see the config UI that allows us to set the lighting threshold and minimum duration for the floodlight, which is simulated using the shield LED. When the passive infrared sensor detects motion and actual lighting is below the threshold, the floodlight switches on for the minimum duration. In the project class diagram, we can see the different class dependencies. Trigger reads from the light-dependent resistor and the passive infrared sensor, and floodlight controls the lighting duration. The config model implements model binding for the submitted HTTP post values and configures the trigger and floodlight with those values. The layout view classes implement a master web page that has navigation links, and the controller filters the HTTP request and serves an appropriate view. The client script in the config view submits the form values, and also take a look at the main application loop. Be sure to download the code and adapt as required. Model binding is covered in my book, Arduino Web Development Pushing the Limits. A major advantage of using Visual Studio Code is that dynamic HTML and JSON content can be authored using Arduino server pages or ASPs. ASPs feature server-side scripting tags that professional web developers will be familiar with. To be able to use ASPs, follow the guidance on my website to configure your computing environment. New web projects can be created from the command line and opened in Visual Studio Code. If I now deploy to an Uno with Ethernet capability, we see starter web pages and a responsive navigation menu. If I paste some code into one of the ASPs and redeploy, when I refresh the browser, we can see the updated web page. And that is how straightforward it gets when you integrate the View Builder with Visual Studio Code. If you have any questions about this project, please leave a comment at my website, and remember to visit for updates and new tech projects. If you're watching on social media and found this presentation useful, please like and share. Thank you for watching.